2,000 years ago, someone built a machine that could predict the future. Not with magic, not with prophecy, with mathematics, with gears, with astonishing precision. And then we forgot how. In 1901, off the rocky coast of a small Greek island, sponge divers searching the seabed stumbled upon something extraordinary. At first, it looked like nothing more than a corroded lump of bronze, just another artifact from a sunken Roman ship. But hidden inside that hardened mass was a secret. When scientists carefully examined it, they discovered intricate gears, dozens of them, interlocked with a complexity no one thought possible in the ancient world. This device was over 2,000 years old, and it should not have existed. It could track the movement of the sun, the moon, perhaps even the planets. It could predict eclipses decades in advance. It even knew when the Olympic Games would occur. Historians now call it the world's first computer. But here's the real mystery. If the ancient Greeks could build something this advanced, why did the technology disappear for more than 1,000 years? What else did we lose? And who was brilliant enough to design a machine that would not be meshed again until the Middle Ages? Tonight, we uncover the story of the most mysterious device of the ancient world, the machine that rewrote history, the Antikythera Mechanism. The year is 1900. In the restless waters of the Aegean Sea, a small boat drifts near a rocky island few people ever visit. Its name is Antikythera. Wind cuts across the cliffs. The sea is cold. Winter is approaching. On board the vessel is a team of sponge divers. They are not explorers, not archaeologists, just working men searching for natural sponges before the storm season begins. One diver fastens his heavy copper helmet. Thick canvas suit, weighted boots, he steps over the edge and disappears beneath the surface. The descent is slow, light fades with every meter. The water grows colder, the silence deepens. 30 meters below, the seabed begins to appear through the blue haze. At first, it looks like scattered rock. Then he sees a face, not a living one, a bronze statue, half buried in sand, an arm reaching upward, another body nearby, marble, bronze, horses. Human forms frozen in time. The diver panics. When he surfaces, he reportedly tells the captain, there are dead men down there. But they were not dead men. They were statues, ancient statues. The remains of a Roman cargo ship that had sunk nearly 2,000 years earlier. What the divers had discovered was one of the richest ancient shipwrecks ever found. Over the following months, with crude equipment and dangerous conditions, divers returned again and again to the site. They recovered treasures the ancient world had not seen in centuries. Bronze warriors, marble gods, jewelry, glassware, coins, artifacts from the height of Hellenistic civilization. The ship had likely sailed around 100 BCE. It may have been transporting looted Greek art to wealthy Roman elites, or perhaps delivering masterpieces to a powerful patron. No one knows for certain. But among the statues and luxury goods, something else was lifted from the seabed. Something small, something unimpressive. It looked like nothing more than a corroded lump of bronze and stone, cracked, green with oxidation, broken into fragments. It did not resemble treasure. It did not resemble art. It was simply catalogued and transported to Athens along with the rest of the cargo. There, inside the National Archaeological Museum, it sat quietly. Months passed. Then, one day, a worker examining the fragments noticed something unusual inside the cracked surface. There were shapes, regular shapes, not random corrosion, teeth, tiny triangular teeth carved into bronze, gear teeth, precise, mechanical, ancient. At first, no one could believe it. The ancient Greeks were known for philosophy, mathematics, architecture. But complex geared machinery? That was thought to belong to a much later age. Medieval Europe. Renaissance clockmakers. Not the world of Socrates and Plato, yet here it was. Pulled from a ship that had sunk in the 1st century BCE, a machine hidden inside a stone. As the fragments were carefully separated, more gears appeared, interlocking wheels, axles, intricate mechanisms compacted into a device no larger than a shoebox. This was not decoration, this was engineering. But how advanced could it really be? Was it a simple calendar, a navigational tool, a damaged clock from a later period? Some scholars initially dismissed it. They assumed it must be contamination, perhaps a more recent object mixed into the wreck, because the alternative was unsettling. If this mechanism truly dated to 100 BCE, then the ancient world had achieved a level of mechanical sophistication far beyond what anyone had imagined. And if they had achieved it, why had it vanished? Why did no other device like it survive? Why did history seem to forget it entirely? The sea had protected it for 2 millennia. Saltwater had corroded its surface, but it had also sealed its secret. Inside that broken bronze lump was a story that would take more than a century to fully uncover. A story not just about a shipwreck, but about lost knowledge, lost science, lost technology. The divers searching for sponges had stumbled onto something far greater than treasure. They had found a machine out of time, and they had no idea. Act 2. A machine out of time. The fragments sat quietly in museum drawers for years. At first, they were nothing more than corroded bronze plates, green with oxidation, cracked by centuries beneath the sea. Compared to the statues and treasures recovered from the shipwreck near Antikythera, they seemed insignificant. But hidden inside those fragments was something extraordinary. As researchers began examining the pieces more closely, they noticed patterns. Not random corrosion, not decorative shapes. Gears. Small, precisely cut bronze gears with evenly spaced triangular teeth. Interlocking. Purposeful. This was not simple craftsmanship, this was engineering. Careful cleaning and reconstruction revealed an intricate system of more than 30 gears, layered within what had once been a wooden case roughly the size of a shoebox. On one side, there had been a hand crank. Turn it, and the gears would begin to move in coordinated motion. But what did they control? Modern X-ray imaging and 3D scanning would eventually expose the true complexity of the device. Gear trains were stacked in multiple layers, each connected to dials on the front and back. The front dial appears to have displayed the positions of the sun and the moon as they moved through the zodiac. A small rotating sphere indicated the phases of the moon, new, quarter, full, waning accurately reflecting its changing illumination. The back of the mechanism was even more astonishing. One spiral dial tracked the Saros cycle, an 18-year period after which eclipses repeat in a predictable pattern. Another dial followed the Metonic cycle, a 19-year system aligning lunar months with solar years. In practical terms, this machine could predict eclipses years, possibly decades, in advance. And some researchers believe it went even further. There is evidence suggesting the mechanism may have modeled the motion of the known planets, Mercury, Venus, Mars, Jupiter, and Saturn, using complex Greek astronomical theories. If true, the device was not merely a calendar. It was a mechanical model of the cosmos, a universe in bronze. What makes this discovery so unsettling is its date. The ship that carried the mechanism sank around 100 BCE. In the commonly accepted timeline of technological development, devices of comparable mechanical complexity will not appear again until medieval Europe, more than 1,000 years later. Yet here was proof that ancient engineers had mastered intricate gear systems long before the rise of mechanical clocks. This was not a crude prototype, it was sophisticated, deliberate, mathematically precise. Every gear ratio had been calculated to mirror celestial cycles. Every movement translated astronomical theory into physical motion. Someone had taken the abstract mathematics of the heavens and transformed it into a working machine. And then, somehow, that knowledge disappeared. Why do we not find workshops full of similar devices? Why are there no surviving manuals describing their construction? Was this instrument extraordinarily rare, reserved for scholars or wealthy patrons? Or was it part of a broader tradition of scientific technology that simply did not survive the passage of time? Bronze was valuable. Old machines could be melted down. Wooden cases would decay. Only this one, sealed by the sea, escaped destruction. If that is the case, then the Antikythera Mechanism is not a lone anomaly. It is a survivor. A fragment of a technological world that history forgot. And its survival forces a difficult realization. The ancient world was not technologically primitive. It was capable of astonishing innovation. The machine from the depths was not just an artifact. It was evidence. Evidence that 2,000 years ago, human beings built a device that could calculate the movements of the heavens, using nothing but bronze, geometry, and genius. Act 3. The mind. Behind the machine. By the time the mechanism's complexity became clear, one question rose above all others. Who could have built this? The Antikythera Mechanism was not the product of simple craftsmanship. It required advanced mathematical knowledge, precise metalworking, and a deep understanding of astronomy. It was the physical expression of theory geometry translated into gear teeth. To understand its creator, we must return to the intellectual world of the Hellenistic age. Around 100 BCE, the Greek world was alive with scientific inquiry. Cities like Alexandria and Rhodes were centers of learning, where scholars studied mathematics, astronomy, mechanics, and engineering. This was not an age of superstition, it was an age of calculation. Greek astronomers had already measured the circumference of the Earth. They had mapped the stars. They had developed geometric models to explain planetary motion. One name often enters the conversation: Archimedes. Living in the 3rd century BCE, Archimedes was a mathematician and engineer of extraordinary brilliance. Ancient writers described devices he constructed, machines capable of modeling the motion of celestial bodies. Roman accounts speak of a mechanical sphere that displayed the movements of the sun, moon, and planets. The description is strikingly similar to what the Antikythera Mechanism appears to have done. But there is no direct evidence linking Archimedes to the device. He lived nearly a century before the shipwreck. If anything, his work suggests something even more intriguing, that such mechanical modeling was not impossible in his time. Another figure may offer a stronger connection. Hipparchus of Rhodes, a 2nd century BCE astronomer, developed one of the most sophisticated lunar theories of the ancient world. He identified the irregular motion of the moon and introduced mathematical corrections to account for it. Remarkably, modern analysis of the mechanism reveals a gear system that replicates that same irregular motion, using an ingenious offset gear arrangement to simulate the moon's variable speed. This detail is not accidental. It reflects advanced astronomical theory embedded directly into machinery. If Hipparchus did not build the device himself, his work may have influenced the person who did. The island of Rhodes, where Hipparchus worked, was also a major center of mechanical engineering. It housed workshops, schools, and skilled artisans capable of precision metalwork. It is possible, perhaps even likely, that the mechanism was created in such an environment, a collaboration between scholar and craftsman, one calculating celestial cycles on parchment, the other shaping bronze to embody those calculations. The result was not simply an instrument. It was a mechanical model of the universe as understood by Greek science. But if this knowledge existed, why does only one mechanism survive? Perhaps it was an elite object, commissioned by a wealthy patron. Perhaps it was used for teaching astronomy to privileged students. Perhaps it was a prized possession, carried aboard the Roman ship that sank near Antikythera. Or perhaps devices like this were more common than we imagine. Bronze was valuable. Old mechanisms could be dismantled and melted down. Their wooden casings would rot. Only this one, preserved by the sea, avoided destruction. If so, the Antikythera mechanism is not an isolated miracle, it is a remnant. A single surviving example of a technological tradition that has otherwise vanished. The mind behind the machine remains unnamed, no signature, no inscription declaring authorship. And yet, their intelligence is unmistakable. Every gear ratio reflects mathematical precision. Every dial encodes astronomical cycles. Every component reveals a deep understanding of both theory and mechanics. Whoever designed this device did more than build a tool. They built a universe in bronze. And for centuries, their achievement lay hidden beneath the sea, waiting to challenge everything we thought we knew about the ancient world. Act 4. The Hidden Inscriptions. For decades after its discovery, the Antikythera mechanism remained only partially understood. The gears were impressive, the astronomical functions were astonishing, but there was something even more revealing hidden within the fragments. Text. Tiny, engraved Greek inscriptions etched into the bronze plates. At first, they were nearly impossible to read. Corrosion had eaten away at the surface. Letters were faint, broken, incomplete. But in the early 21st century, modern technology changed everything. Using high-resolution X-ray tomography and advanced imaging techniques, researchers were finally able to look inside the fragments without dismantling them. What they found was extraordinary. Hundreds, possibly thousands of characters engraved into the metal. Not decorative text, not ownership marks. Explanatory text. The inscriptions functioned almost like a user manual. They described astronomical cycles. They labeled dials. They explained eclipse predictions. They even referenced colors that would have once been painted onto the display. This was not a mysterious ritual object. It was a scientific instrument meant to be understood. One section describes the Saros cycle in detail, explaining when eclipses would occur and whether they would be solar or lunar. Another section references planetary phenomena. The device did not merely calculate, it communicated. The text suggests that the mechanism was designed for an educated user, someone familiar with astronomical terminology but still in need of guidance. It was a teaching tool, a demonstration device, perhaps something a scholar would use to show students how the cosmos moved in predictable cycles. The inscriptions also confirmed something else. The language and letter form stayed precisely to the Hellenistic period. There was no medieval contamination, no later addition. The machine truly belonged to the ancient world, and that confirmation removed any lingering doubt. The Antikythera Mechanism was not an anomaly from a later era. It was genuine, 2000 years old. Its creators did not rely on mysticism to explain eclipses. They relied on mathematics. They encoded their understanding of celestial cycles into bronze gears and explanatory text. In many ways, this makes the mechanism even more powerful. It is not simply an artifact of advanced engineering. It is evidence of a scientific mindset, a worldview built on prediction, measurement, and rational explanation. The hidden inscriptions transformed the mechanism from a puzzling relic into a documented scientific instrument. They gave voice to its creators. And through those faint Greek letters, we hear something remarkable. The ancient world did not merely observe the heavens, it sought to calculate them. And in doing so, it came closer to building a mechanical model of the universe than anyone would achieve again for over a millennium. The sea preserved the gears. Modern technology revealed the words. Together, they uncovered a forgotten chapter of human ingenuity, one engraved not only in metal, but in the history of science itself. Act 5. Why was it lost? By now, the brilliance of the Antikythera mechanism is undeniable. It predicted eclipses, modeled celestial motion, encoded advanced astronomical theory into bronze gears, which leads to the most unsettling question of all. If the ancient world could build this, why did the knowledge disappear? The Hellenistic era was one of extraordinary intellectual energy. Scholars measured the Earth's circumference, mapped the stars, and debated the structure of the cosmos. Mathematics was not abstract philosophy. It was a practical tool used to understand reality. In cities like Alexandria and Rhodes, learning was institutional. There were schools, libraries, patrons, and communities of thinkers who built upon one another's work. But knowledge depends on stability, and stability is fragile. In the centuries after the mechanism was built, the Mediterranean world changed dramatically. The Roman Republic transformed into an empire. Civil wars reshaped political power. Economic systems shifted. Priorities changed. Over time, the centers of Greek scientific learning declined. Libraries were damaged or dispersed. Workshops closed. Teachers died without passing on their full expertise. Scientific traditions are not self-sustaining. They rely on networks of students, craftsmen, mathematicians, and patrons. If that network fractures, even brilliant knowledge can fade. Mechanical technology is especially vulnerable. Unlike written texts, machines do not copy themselves. They must be rebuilt piece by piece by people who understand how they work. Bronze was valuable. Old instruments could be dismantled and melted down, their gears reused, their wooden casings decayed. If only a small circle of experts knew how to construct such devices, the disappearance of that circle could mean the end of the technology. There is also a cultural shift to consider. Roman engineering excelled in practicality: roads, aqueducts, fortifications, military machines. But theoretical astronomical modeling may not have received the same long-term investment. A device like the Antikythera mechanism was not necessary for survival. It was not required to win wars or build cities. It was an intellectual instrument, and intellectual instruments are often the first casualties of instability. Then, centuries later, parts of Europe entered what we now call the early medieval period. Literacy declined in many regions. Scientific texts became scarce. Complex mechanical innovation slowed. It would not be until the great astronomical clocks of medieval Europe, over 1,000 years later, that gear systems of comparable complexity would reappear. The gap is astonishing. For more than a millennium, nothing like the Antikythera mechanism is known to exist. It is as though history briefly leapt forward and then stepped back. But perhaps the knowledge was not entirely erased. Greek scientific works survived in the Eastern Roman Empire, and later in the Islamic Golden Age. Scholars translated, preserved, and expanded upon ancient astronomy and mathematics. Ideas continued to move. Yet, the physical tradition of constructing intricate mechanical cosmos modeling devices seems to have faded. The mechanism reminds us that progress is not a straight line. Civilizations rise, they innovate, they reach heights that seem unimaginable, and then they can fragment. The Antikythera mechanism is more than a relic of ancient genius. It is evidence that human capability has surged forward before long before the modern age. and it challenges a comforting assumption that we stand at the very beginning of technological sophistication. Perhaps we are not the first to feel on the verge of mastering the universe. Perhaps others came close, and perhaps, without the accident of a shipwreck near Antikythera, we would never have known. The sea preserved the machine, but it also preserved a question. How much of our own knowledge, if left unprotected, could vanish just as easily? History does not guarantee continuity, it only guarantees change. And sometimes what is lost must wait centuries to be rediscovered. Act 6. A message across time. When the Antikythera Mechanism was pulled from the sea, it was silent, corroded, fragmented, nearly unrecognizable. Yet within its bronze gears lay something extraordinary, not just a machine, but a message. A message from a civilization that refused to accept the sky as mystery. For centuries, the stars had inspired myth. Gods pulled the sun across the heavens. Titans controlled the moon. Eclipses were omens. Comets were warnings. But the creators of the mechanism saw something different. They saw patterns. They saw cycles. They saw predictability. And instead of telling stories about the heavens, they built a machine to calculate them. This is what makes the Antikythera Mechanism so powerful. It is not merely ancient technology, it is ancient rationality. The device represents a worldview built on mathematics, the belief that nature operates according to laws that can be measured, modeled, and understood. Turn the crank and the cosmos moves, not randomly, not spiritually, but mechanically. In that sense, the mechanism is not just a precursor to the medieval clock. It is a precursor to the scientific revolution. It embodies an idea that would not dominate Western thought until nearly 2000 years later, that the universe is knowable through calculation. And yet, this idea was already alive in bronze around 100 BCE. When we look at the mechanism today, displayed in glass cases and studied with advanced scanners, we are not simply observing an artifact, we are witnessing continuity. Modern computers simulate planetary motion. Space agencies predict eclipses with perfect precision. Astronomers model the expansion of the universe. All of it, in some distant philosophical sense, echoes the same impulse that drove the ancient engineers of the Antikythera Mechanism. To understand, to predict, to build knowledge into physical form. There is something humbling in that realization. We often imagine the ancient world as primitive, intellectually impressive perhaps, but technologically limited. The mechanism disrupts that narrative. It shows us that brilliance is not confined to modernity. It reminds us that intelligence has always been part of the human story. And it raises a final, profound question. If this level of engineering and astronomical understanding existed over 2000 years ago, what else have we underestimated? How many discoveries have been lost because the material evidence did not survive? How many ideas flourished briefly, only to fade into silence? The Antikythera Mechanism survived by accident. A ship sank. The sea sealed it. Time forgot it. And then, by chance, it was found again. History is filled with accidents. What we know about the past often depends not on what was created, but on what happened to survive. The mechanism stands as a symbol of that fragile thread connecting us to earlier minds. It is proof that innovation can appear long before it becomes widespread. Proof that progress can stall. Proof that knowledge can vanish. And proof that it can return. Today, we decode its gears with digital technology. We read its inscriptions with X-rays. We reconstruct its missing pieces with computer models. In doing so, we complete a conversation interrupted for 2 millennia. The ancient engineer who built this device could never have imagined satellites, telescopes in orbit, or spacecraft leaving the solar system. Yet they shared something with us, a belief that the universe follows rules, and that those rules can be understood. The Antikythera Mechanism is not simply the world's first known analog computer. It is a bridge between myth and mathematics, between antiquity and modern science, between the forgotten past and the technological present. And perhaps its greatest legacy is this: human curiosity does not belong to one era, it belongs to all of us. 2000 years ago, someone turned a crank and watched the heavens move in bronze. Today, we run simulations and watch galaxies unfold on screens. Different tools, same desire: to understand the cosmos and our place within it. 4,000 years ago, a ship sank near Antikythera carrying more than treasure. It carried proof. Proof that the ancient world could measure the heavens with gears and mathematics. Proof that curiosity and engineering did not begin in the modern age. The Antikythera Mechanism reminds us that history is not a straight line. Knowledge can rise, vanish, and return. Somewhere in the ancient Mediterranean, an engineer built the universe in bronze. Today, we are still trying to understand it. If you enjoyed this journey into lost technology and ancient mysteries, subscribe for more deep dives into the forgotten chapters of history. Because sometimes the future begins in the past.